Hello all. In this session, we will discuss about doubly linked list. Here, it is a type of linked list where each node contains a data field, a reference to the next node, a reference to the previous node. You can see in the below diagram. Here, the data field. Here is the reference for previous node. This one is for next node. If you see sample diagram for doubly linked list with multiple nodes, you can see here we have three nodes. This is the first node, this is the second node, this is the third node. In each and every node, we have previous reference data and next reference. The first node is having data 55, the second node is having data 65, and the third node is 75. Head points to the first node. If you see the node address, the first node address, that means where it is staying in the memory, location of that address is 200 for first node. For second node address is 400, third node address is 800. And if you see the first node, previous reference is null. And if you see the second node previous reference is 200. That means second node previous holds the first node memory location address, that is 200. Likewise, the third node holds the second node memory location address, that is 400. This is for previous. And if you talk about next, the first node holds the memory location of second node's address, that is 400 in the next reference. Likewise, second node holds the third memory location address, that is 800 in the second node next reference. The last node, if you see next points to null, it doesn't have any other nodes further. This is the structure of doubly linked list. And if you observe in the previous session, we discussed singly linked list. Nodes, each and every node is having data and reference to the next node. There is no previous reference. Okay. And mainly, if you talk about singly linked list and doubly linked list structure, we know in singly linked list, each node contains data and a pointer to the next node. In doubly linked list, each node contains data, a pointer to the next node, and a pointer to the previous node. Memory usage. If you talk about memory, singly linked list requires less memory as it stores only one pointer, next pointer. If you talk about doubly linked list, it requires more memory due to the additional pointer for the previous node. We have previous node in the doubly linked list. Traversal can only be traversed in one direction, forward for singly linked list. In doubly linked list can be traversed in both directions, forward and backward. About insertion and deletion of the nodes in singly linked list, it is easier at the head but more complex elsewhere. About doubly linked list, it is easier at any position as you can access both previous and next nodes directly. So we can traverse forward and backward. So it is easy. Performance. If we talk about performance, slightly faster due to fewer pointers to manage in the singly linked list. And about doubly linked list, it is slower due to additional pointer updates. Use cases. Suitable for simple applications like stacks or queues for a singly linked list. And doubly linked list, it is suitable for complex application like navigation systems or undo redo functionality. We'll see the node class for a doubly linked list. This is the class node definition. Data, the data node holds self data equal to data, self dot previous equal to none, self dot next equal to none. Previous pointer to the previous node, next pointer to the next node. We have doubly linked list class. This is the class. Here head equal to none, head of the list, nothing is there in the list. Now if you see insert at the end, we have a function append. Definition in the append function, we have new node equal to node data. Node will be initialized here. Again conditions like we have seen in the singly linked list, similar way only. If self dot head is none, that means list is empty. Self dot head equal to new node. Return. Traverse to the end. we have a temp reference that equal to self dot head. We need to traverse from starting to end, while temp dot next, temp equal to temp dot next. We'll have to traverse till we find the last node. When we find the last node, we need to append new node. That means temp dot next equal to new node, link new node at the end, new node dot previous equal to temp, set previous of new node. If you see the diagram, whenever we find the last node, we need to do these two. Okay. After insertion, let us see sample diagram here like this. Node address we have seen previously, right? The same way. This is a first node, this is a second node, this is a third node, this is a fourth node. Insert at the beginning. For that we have function named prepend. Here also node initialization will be done with the passed data new node dot next, because we are going to insert a node at the beginning itself. Here new node dot next equal to self dot head. New node points to old head. If self dot head dot previous equal to new node, self dot head equal to new node. We need to update the head pointer. If you see the picture, insert the new node at the beginning. Let us say new node data is 95. Initially, previous and next pointers are pointing to null. After inserting 95, the list becomes like this. The first node 95 followed by other nodes 55, 65, 75 and 85. Okay, we'll run this code and check the result in Visual Studio Code. This is the main code. This is the instance creation for list. DLL equal to doubly linked list. We are appending 55, first node, second node 65, third node 75, fourth node 85. This is the data we are passing. And after that, after appending, we are displaying the data with display forward function. We'll also copy display forward. We'll see what it is there. This is the display forward function to display the doubly linked list data items. So first we are taking reference temp pointer, temp equal to self dot head, temp is pointing to head, while temp print temp dot data. We need to traverse from beginning to end of the linked list, and we are printing the data temp equal to temp dot next. From beginning it take the data and print and go to the next node and print the data, go to the next node, like that. The loop traverses from beginning to end of the linked list and print the data. We copy this. Yeah. We'll see display backward later on. We'll run this code, save the file, run. So what is the result we need to get? 55, 65, 75, 85. These are the initial data. Okay. And then we are displaying the data. Output is this one. And after that, we wanted to insert 95 data node in the beginning of the linked list with the prepend function. Okay. After prepend the data 95, then we are again displaying by using display forward. Now 95th node data should appear first, 95th, then followed by rest of the nodes. We'll run now. Yeah, you can see here the result is correct. That's all for this session. We'll see another methods for a doubly linked list in the next session.